So thank you again for joining us for today's webinar. I'll just give you a brief rundown of Maine Lake Society. We are a statewide lake conservation organization. Our flagship program is Lake Smart, which is a homeowner education and incentive program. We love to support our Lake Association members and are working every day to try to find new ways and better ways to support them in the important work they do. We have a Lakes Alive outdoor ed program. It's on a bit of a hiatus this summer, given the conditions. So we are working to revamp and improve that program. And then we are in Augusta every session, working with legislators and grassroots activists to get good lake-friendly legislation in the books in Augusta and sometimes in DC. So for more information, visit our website. We'd love to have you as a member. So I'll just do a brief introduction of our speaker today. Don Griggs has spent some part of almost every summer on Kezar Lake and the forests of its watersheds since 1952. That's a long time to be spending on a beautiful lake in a beautiful part of the state. In 1969, Don bought a cottage on the lake and his family spent most of their summers there while his 3 sons were growing up. What a great way to grow up on a lake in Maine. Don graduated from Johns Hopkins University in electrical engineering and has a master's in nuclear physics. He served 27 years in the Army Signal Corps in various command and staff positions with tours in France, Germany, Korea, Vietnam, and Thailand, as well as several places in the US. Don joined the Kezar Lake Watershed Association board in 2013. And serves as the director of the Climate Change Observatory. And he also leads many other KLWA projects, such as the Boat Wake Awareness Program that he'll tell us about today. So without further introduction, Don, I think I can help get you back here. There you are. Hi, Don.
Hi.
All right, it's all yours.
Okay, well, let me get this
sorry.
screen share thing going here.
Yep, I was gonna say it's not quite all yours because I have to turn my screen off, but they're screen sharing off, but you should be able to do it now.
Okay, do you have me?
Got it, good.
Okay. Well, as Susan said, my name is Don Griggs. I want to thank Susan and the Maine Lake Society for inviting me to speak today about a topic that we've been very concerned about, and more so as time has gone on here. The Kezar Lake Watershed Association, KLWA, is celebrating its 50th, or has celebrated its 50th anniversary. So we've been around a while. Like most lake associations, our purpose is to preserve, protect, maintain ecological, scenic, recreational resources of our lake and its watershed for the benefit of all of our residents for now and in future generations. We've been a leader in protection of the lake. We work with local officials to promote safety, water quality, and the normal things lake associations do. We maintain a comprehensive, scientifically based water quality research and monitoring program, and we encourage lake residents to understand, to participate in our activities, to learn about things pertaining to the lake and the watershed. And these wake things are a key example. 7 years ago, we established the Climate Change Observatory to observe, measure, and analyze long-term climate change trends and to assess their impact upon the lake, lands, waters, and wildlife. We have an extensive website at klwa.us that has reports on water quality, climate, loons, lake patrol, fisheries, and a lake dwellers handbook, which greatly advocates Lake Smart and other things. We also have a 24/7/365 weather station and webcam on our website so that people can get a fix for our lake year-round whenever they want. We're a 501c3 nonprofit organization, and we rely on contributions from our members and from grants. This presentation addresses the problems generated by slow-speed powerboat activities, especially boat wakes generated in the sports of wake surfing, wakeboarding, and slow-speed tubing. We're particularly concerned about slow-speed boating in shallow water, and we'll talk about that. Shallow water means less than 20 feet. To show you where we are, our watershed is 56 square miles. It's 20 miles due east of Mount Washington, New Hampshire. So we're right on the Maine, New Hampshire border. The watershed is about 92% forested. The lake, which you see is about 9 miles long. It's 2,900 acres, and there are 6 small ponds in our watershed as well. Over here on the west side is Horseshoe Pond, and I'll be mentioning that in another few slides. The lake drains to the south into the Saco River. This lower bay part is of special interest because it averages 10 feet deep. The deepest part of the lake is up here, and it's 155 feet deep. Most of the lake all down through here is from 20 to 80 feet deep. So it's relatively deep lake. This is a view from our webcam about midway down the lake. And I just show this to give you a feel for the size and the nature of it. This was just before or during ice out. And we're looking west. And if you look over here at this snow-covered mountain, that's Baldface. If anybody has ever climbed Baldface, then you know where that is. That's a very famous hiking mountain. So as the years pass, we've seen more and larger boats on our lake. There's also a lot more small craft, kayaks, paddleboards, canoes, and so on. And these wakes certainly can cause damage to these small things, to docks, to boats, scour the bottom. So we're contacting other lake associations to get their observations and opinions as to what to do about this. And we're seeking ways to mitigate and control inappropriate boating activities. You'll see that we're establishing guidelines for responsible boating. We are focused on education, 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 and we're also considering or hoping that some legislation can be done relative to wake surfing. I show this slide because it's part of our climate change results. We did sediment cores in Kezar Lake back in 2015. And this is one of the analysis slides that came out of that. And this represents the accumulation rate of sediment in the lake. And as you can see, since 1980, this sediment rate has gone up like a rocket. So the question is why? Why did this happen? And there has been no change in the nature of our landscape. There's been no development, no increase in farming. There's no reason for this. So after a couple of years, we've been thinking about what could this be? And we decided maybe it's boats, because we're getting a lot more boats and a lot bigger boats. So this past February, we decided to take a core in Horseshoe Pond, which I showed you earlier. And this pond is pristine. It has no boat wakes. And it's about 40 feet deep. And so we have taken that core, and we haven't gotten the analysis yet because the COVID-19 mess has seriously impacted the analysis, which is being done by Plymouth State University. As an aside, at the same time we did this core in Horseshoe Pond, we had a professor from Dartmouth who wanted to do a ground penetrating radar of the pond. So at the same time, he came over and did that ground penetrating radar, which is very, very interesting. It's got nothing to do with wakes, but it has to do with our understanding of sediment and erosion. So this radar penetrated 15 inches of ice, 40 feet of water, and 20 feet of sediment and debris in the bottom of the pond. And he, Dr. Arcone, who did this, said that the pond was twice as deep back 12,000 years ago when it was gouged out by the glaciers. So I just thought that was a very interesting fact. And there's lots of actions that cause this sediment to occur. And we'll see what the analysis turns out to be here. Okay, there's two kinds of things that we're focused on here, as we mentioned. One of them is the creation of wakes, and the other one is the bottom scouring. So what's the threat from these wakes? These specialty boats called wakeboats, when operated in the wake surfing mode, generate 4-foot wakes that are a serious threat to the lake, its water quality, safety of other boaters, and personnel and property along the shore. The 200-foot no-wake zone that is main law is seriously inadequate to protect the shorelines from erosion and damage from these big waves. Another threat comes from the slow-speed boating in shallow water, where the propeller wash interacts with the lake bed and stirs up the sediment and destroys the vegetation and the aquatic habitat. So what kind of boats are making these waves? Well, we got boats with virtually no wake, wind or muscle-powered boats. Then we have boats with little to moderate wake, like 4 to 12 inches. So low-powered boats, personal watercraft fit this category. Boats with medium wakes, 1 to 2 feet. We have general runabout boats, ski boats, pontoon boats. Boats with large wakes, 2 to 4 feet, are the wake boats in the wake surfing or wake boarding mode. General runabouts operating at slow speed. Very large boats that are more than 24 feet long. And occasionally we get a cabin cruiser that's more appropriate for Casco Bay than it is for a lake. It's particularly a small lake, but they show up once in a while. All boat wakes vary significantly depending on the boat speed, and I'm going to talk about that. So this chart talks about the activities that cause these wakes. For the medium wakes, the general touring of the lake at these speeds, you get 1 to 2 foot wakes. Water skiing is usually pretty fast, and they don't have much wake. Water ski boats, dedicated water ski boats, have very small wake. In fact, the skiers do not want any wake. Then we have tubing at high speed, meaning 15 miles an hour or more. Then we have fishing, the high-speed bass boats, the way they go by our place on the lake at 60, 70 miles an hour, there's virtually no wake, they're flying. And then the boat activities with large wakes, tubing at slow speeds, 1 to 3 feet, wakeboarding, 2 to 3, wake surfing, 4 or more, and then the large boats that I mentioned. Now, the slow speed tubing is something that most people just don't think about. And as Susan mentioned, I have 3 sons who grew up on the lake. I have 8 grandchildren who grew up on the lake. And I personally taught them how to ski and to tube. And when I was teaching them, particularly to ski, we would stand in the water, you know, maybe 4 feet deep or so, and help the kids get the skis under control and the rope and all of that. And we'd make a start, and they'd probably fall several times. And you keep doing that. Well, eventually they get up. But in the meantime, I had no idea what I was doing to the bottom of the lake, because the boat, once you throw the power to it, the bow goes up and the thrust goes down and it's tearing up the bottom. And I didn't know that. And that's part of our problem now, is that most people don't know that. So particularly you have a grandfather who's teaching the grandkids how to tube or to ski, and they're doing these things in the shallow water and they don't know what's the consequence. Okay, here's something about the nature of boat wakes. There's 2 kinds of activities here. Displacement waves caused by the bow, where the boats are plowing the water. And the other are planing waves, which are called transverse waves that generate from the stern and from the propellers. Now, classically, boat wakes decay according to a mathematical formula such that the wave height reduces by half for every 8-fold increase in distance from the sail line, that is, the path of the boat. This chart shows that a 4-foot wake decays to 2 feet at 160 feet and down to 1 foot at 1,280 feet. So that's quite a ways out. Now, a 1-foot wake is kind of non-trivial. And the height of the wake is measured from the trough to the top of the wake. Okay, here's a chart that is showing how the wake versus speed comes down. The wave height is on the vertical axis and the speed of the boat is on the horizontal axis. So you can see that there's a range there where it maxes out. If you're going slower than that, like here it's about 6 miles an hour, then the wave height is not so much. And if you're going fast, the faster you go, the less height you have in the wave. Now this chart shows the wave height at various distances for various wave heights. So you can see that for the 4-foot wave we've been talking about, at 300 feet, at 400 feet, at 500 feet, and here's the 1-foot height, which I mentioned. And if you're at 3 feet, out at 500 feet, it's only about a foot. And if it's less than that, then it's significantly less. So what we said is, how about selecting 500 feet as the standoff distance for very large wake activities? The current main law of 200 feet for no wake, starting at 2+ feet, seems to be reasonable. Now, I will tell you also that I have researched, I've researched for hours and hours and hours about all of this stuff. One of the studies that I found was a Canadian study that did extensive testing on wake boat wakes. And they recommended that wake surfing activities be conducted at least 1,000 feet from shorelines to avoid erosion. Now, again, I said, we're looking at 500 feet. And we picked 500 feet as a reasonable compromise between what people might abide by. If we had 1,000 feet on our little lake, they would probably just blow it off and not do anything. So that's why we decided to go with 500 feet, even though we get a wake that's higher than we would like. Okay, so we're especially concerned about wake boats. These boats are designed to make very large wakes, and they're used to support the relatively new sport of wake surfing. Although they're expensive, they're proliferating. We have had many complaints about the large wakes these boats create. Now, we're not as concerned about the wake boats per se, but how and where they're used. I will tell you that there are some boats, one manufacturer called Pravati that makes an all aluminum wake boat. It costs $250,000 to $300,000. It is computer controlled, and you can just press buttons to whatever activity you want. If you want to wake surf to the left, wake surf to the right. If you want to wakeboard, if you want to water ski, if you want to tour, you just press a button and the boat configures itself to do those things. And if it's wake surfing, it'll take on the 5,000 pounds of water that is necessary for that. So these wake boats are marvels of engineering, and we aren't trying to control wake boats to say that we don't want them on our lake, but we are trying to control how and where they are used. Here's some typical specifications for these boats. They're pretty big boats, 22 to 26 feet long, 8.5 feet wide, weigh upwards of 10,000 pounds, hold a lot of people. They hold 5,000 pounds of ballast. They have big engines, and they cost a lot of money. Now, there's also some poor man versions of these boats where you can, for $200 or $300, you can buy some vacuum plates that you can slap on the side of any boat to make wakes, like big wakes, not necessarily quite as big as what these dedicated boats will do, but still big wakes. So the other things you can do is to buy bladders for any boat and fill them with water to get that ballast so that the boat sinks in the back and plows more water, makes bigger waves. Here's a video that I'm going to show you. If you're not familiar with what wake surfing is, you can see that this guy has no rope. There is no bindings on the board, and they're in there to do tricks. They're trying to emulate ocean waves, and you can see that these wakes are pretty big, and they're going along on the edge of it. Another good thing about this sport is that if you fall, you're going so slow that it's about like falling off the dock. It's no big deal. So that's just a quick view of some wake surfing. And you can see the size of the wake here in this end part of the video. It's pretty big. So what should we do about addressing large wakes? Well, creating guidelines for using these things on our lake. And then again, educating, signs, instructions by the marina staff. They're very good at that. KLWA has a lake patrol boat that is on the lake on busy times, so they will help get this word out too. And then to seek the support of these lake associations to petition Maine legislatures to help wake surfing, establish wake surfing regulations. So what guidelines are we talking about here? Well, we've kind of already described what it is. Wake surfing should be operated at least 500 feet from shorelines, boats that are underway, anchored or moored. Other boating activities that create large wakes, more, 2 to 3 feet, especially wakeboarding, slow speed tubing, and touring, should be operated at least 300 feet from the shorelines, docks, and so on. Now, in order to keep the time down, I have not run videos of the differences between wake surfing, which I did show you, and wakeboarding. Wakeboarding is done with a rope. It's more like water skiing. but it's using a board, and it may or may not have bindings on the board. And their object is to go out to the side of the boat and rush the wake as fast as they can and launch into the air as high as they can and do all of the Shaun White-like things that he does in the half pipe with spins and flips and turns and all that stuff, and then push, land upright. So that's what the wakeboarding is about. And their wakes are less, but non-trivial. Okay, now let's consider the threat of propeller wash on the bottom. It can have a devastating effect by scouring the bottom, resuspending the sediment, especially phosphorus, destruction of aquatic vegetation and water critters and their habitats. Now, wakeboats have a 20-degree angle on the prop shaft and another 10 or 15 in a bow-up position, so that the prop thrust is about 30 degrees down. The velocity of the jet wash is proportional to the prop pitch and the prop RPMs, the revolutions per minute. And the jet wash speed decays linearly with distance. Now here's a simple graphic that shows what this prop wash cone looks like coming off of a wake boat or any boat. So you can see that the fact that the inboard boats have the propeller already pointing down, and then when you go bow up, it's down a lot more. So it's driving this cone of high-speed water down to the bottom. Now this is a graph that shows a prop speed on the vertical axis and the boat speed on the horizontal axis. And this line shows a jet velocity from an outboard boat that will disturb 0.3 millimeter sand. That's kind of medium sand on the bottom. So if this boat is operating at 9 miles an hour, which seems to be the magic number here, and if you're in 4 feet of water, the velocity will be 80 centimeters per second. And that's very, very fast. If you're down here in 11 feet of water, you're right at the threshold of this standard that the many studies have used. So this is a fairly mundane boat that's doing this, and it's not a wake boat and it's not pointing down. This was from an outboard motor. Okay, I talked ahead of myself there. Okay. So here's the chart we just looked at for the slow speed problem on the bottom. And here's the chart we looked at earlier about waves, the wave height versus speed. Now, if I overlay these two charts, guess what? They both peak at the same speed, about 9 miles an hour, right here. So this is sort of the double whammy if you're doing things in shallow water with powerful boats that are wake surfing or tubing. So they have the greatest adverse effect on the shorelines, the docks, erosion, and all of that if it's done in shallow water. Now, to give you a feel for what this bottom scouring is about, here is a a test that we did. This is my boat you see in there. This is a Sea Ray. It's an 18-foot Sea Ray. We're on the lower bay in 9 feet of water. It's got 130 horsepower stern drive. There was one person in the boat, an underwater camera on a pole, and we had a turbidity meter deployed. We're standing on a pontoon boat here to take this video. And here's the video. You will notice the propeller, it takes off, creates a lot of bubbles. Now watch right in here. You can see the dust cloud or debris cloud starting to come up, and now debris from the bottom is starting to show up. This is significant debris. Here's the turbidity meter clunking around over here. So this really picked up a lot of debris. And again, this is a pretty mundane little boat as compared to many of these other boats we're talking about, especially the wake boats. So this is the same diagram we had before, except now we're looking at a prop thrust of 30 degrees down, 16-inch prop pitch, and a 16-inch prop diameter. And the critical water velocity to disrupt the sediment is 25 centimeters. So I've calculated and plotted all of this. This is at 1,000 RPM, 2,000 RPM, 3,000 RPM, and the wake boats operate in this area down here, somewhat more than 3,000 RPMs. So this is why we have selected 20 feet as the water depth for which we want the boats to be in greater depth than that. So here's the guidelines that we looked at before, 500 feet and 300 feet, and we've added one more paragraph that no such slow speed activity should occur in less than 20 feet of water due to propeller wash. Now, in order to help with the education and to get the word out, we have created this flyer. This is a two-sided plastic flyer, which it's very resistant to getting wet or destruction. And on one side, we talk about being wake-wise, what the concerns are, what the side effects are, what the causes are, and on the other side, what you can do to help. And the main thing here is that we give them a map of our lake, and in yellow, we show them the areas which are 500 feet and from shore and in more than 20 feet deep. So these are the areas which, if they're going to do those wake producing activities, this is where they should do it. Oh, and one more thing. If you weigh more than 200 pounds, we don't want to see any cannonballs in the no wake zone, nothing in less than 20 feet of water. The awesome wake is unacceptable. The shock wave can kill small fish and stir up phosphorus. Really. This is totally bogus, just a little comic relief. But large wakes and bottom scouring are very real, and we hope that boaters on Kezar Lake will follow our guidelines. So what about boaters on your lakes? And that ends my presentation. I would be happy to answer questions. Here's our website down here on the bottom. If anybody wants to go to the website, you can get a whole lot more information about the wakes and all manner of other things. So go ahead.
Yeah, thanks, Don, so much. And the poll has just popped up. Most people answered it pretty quickly. Don was curious to know if people had experienced wake problems. And I think you can see that, Don. It looks like the answer is a resounding yes. That that people have experienced wake problems and have experienced shallow water problems caused by power boats. So definitely something that people are interested in and concerned about. We do have a couple of questions. If we don't, we'll try to get to as many questions as we can, and we will, we have about 5 or 6 minutes. We try to end these right at 4:45 because we find people start trickling off, and we don't want to keep going over our timeline. So I'll answer I'll ask as many as I can. And then Don has, I think, offered, between Don and us, we can try to address the rest of the questions and get it out to you in a follow-up email. I think some of these would be real easy for Don to follow up with. But most important question, I think, from concerned grandparents out there, if you do want to teach kids how to water ski, if you teaching to water ski is a pretty short duration. It's long at the time, but overall short duration. But is there any way that you can teach kids to water ski that doesn't affect the lake bottom?
It's very difficult, and one of the problems we have by showing that map, there's a lot of people that live on that lower bay, and if they had to go all the way up to the main part of the lake, that's a long trip because all through the narrows by the marina, that's all, no wake zone, so it's only headway speed. So it takes a long time. That's a problem. And how do you get people to pay attention to that and not just say, well, I haven't got time for that. The kids are bugging me and I got to do it. So many will just do it. There's no question. One of the good things about the lower bay is that its flush rate is pretty high. It flushes about 3 times a year. So the stuff that you kick up is not quite as damaging for creating algae blooms and all because it flushes. The main part of the lake flushes every 3 or 4 years. So, but then it doesn't have the shallow water problem. So what do you do about the little kids in shallow water? I don't have any great solutions, and that's where I would ask your viewers here, if anybody's got some good ideas on how to do that, we would be delighted to hear it.
Okay, great. A couple people asked about, and I'm not sure if you mentioned this or not, but most of these large wake boats have ballast tanks in them. Is that correct, to make them heavy?
Yes.
And so there's a couple of questions about if you're concerned at all about transferring milfoil or transferring, larvae of invasive aquatic species. Is that something your lake association has talked about? And do you have any suggestions for addressing that concern?
Yes, it is a very big concern. Kezar Lake has no invasives, and we have a massive program funded partially by the town and partially by our association. We inspect every boat that goes in and out of the water. But yes, we are concerned about these ballast tanks flushing because nobody's going to take a boat out of the water when its ballast tanks are full. So it is a very much of a problem. We try to check where boats were last in the water, and if it turns out it's in one of the infected lakes, then we try to convince people that maybe they don't want to put in this lake. But it's a nasty problem. We don't have a good solution for it, but we are acutely aware of the problem, and it worries us a lot.
All right. Let's see. Somebody raised a question about the 200-foot no wake zone, that many boaters are not even aware of that law and that regulation. Do you find on Kezar Lake, with your work with Kezar Lake Watershed Association, is that your finding as well, that boaters are not aware of that law?
No, it's not so much that they're not aware of it, but some people just ignore it. But I think we have to depend on reasonable people doing reasonable things, and most of our people are reasonable people, and they abide by the 200-foot rule. And like going through the narrows by the marina, do you occasionally find somebody that is speeding through there? Yes, you do. But most do not. Most people abide by the law and are aware of it. But we support that in our flyer and our other information endeavors to make people aware of the 200-foot rule as well.
Have you, here's a great question. Have you had any either support or pushback from local marinas or boat businesses about your maps and your push to limit high power, or high power wake boats to those specific areas of the lake?
No, we have not. In fact, Lee Conry, who is the owner of our marina, is 110% behind what we're doing. We keep him informed, and like I mentioned on one of the slides, Lee and his marina staff, if there's anybody that's renting a high-powered boat, he does have a wake boat there for rent, and they instruct them explicitly on where they can do their wake surfing activities.
Great. That's great. Somebody else mentioned, I think this will be our last question, and then like I mentioned, we'll get back to some of the questions because there's some other great questions about lake sizes. Some people were interested in looking at it and in getting a copy of your presentation. I don't know if that's possible. But one last follow-up question. Do you know, have any recommendations or approaches to working with, in this particular instance, a summer camp that has not been engaged, does not seem to be interested in engaging with the Lake Association regarding the use of 3 lake boats? It says they have 2 to 3 of these lake boats running simultaneously on a 700-acre lake every day for hours at a time. Any advice or suggestions for?
Well, if you read the main boating laws, they are very general, but they do have words in there that it is illegal to do things that are dangerous. I'm trying to remember the words, but there's several things in there that if you're doing things that are dangerous or not watching your wake, that's one of the things. You must watch your wake and not cause problems with slamming boats around that on somebody's dock and all that sort of thing. So that's there. Now the problem is, how do you enforce that? And the only people that can enforce it are game wardens. So we work hard to get as much game warden time on our lake as possible, especially with fishing tournaments, although the fishermen are generally pretty good citizens. But we try to get that. And the only thing you can do is take video of these people that are doing bad things and turn it in to the game wardens. So, will something happen? Well, maybe, maybe not. But that's about the only thing that we know that you can do is take video, because if you just go to the wardens and say, well, I got the registration number of the boat, and here's what they did. And he says, well, I didn't see it, so I can't arrest them. So it's definitely a problem, but video would certainly help.
Okay. Well, I think that's this whole issue of wake boats is something that Maine Lakes is going to be working on in terms of, constructive solutions, because, you watch that video, it does look like, it looks really fun to do those things, but we all want to do them in a way that doesn't impact water quality or lake habitat or, sedimentation or all those things.
Now, a quick comment on the other thing you mentioned. Can people have a copy of this briefing? Yeah. It is on our website. It's not quite exactly the same one I gave today, but it's essentially the same. And also, a couple of lake associations have already asked for copies of that flyer, and I give permission to take our flyer, and others have replaced our map with their map. So that's doable too. We're here to help get the word out and make things better all around.
Well, great. Thank you so much for a great presentation. We will get all the rest of the questions to John and see if we can help answer some of the other great questions that came out. Those will all go out to everybody in a couple of days. But quick wrap up. Again, our next webinar is for Lake Smart folks, but the one after that is Saturday at 9:30 on June 20th to listen to Hillary Snook. He's going to be great. Prior to that at 9 o'clock is the Main Lakes annual meeting. And actually, if you register in order to register for Hillary Snooks, you register for our annual meeting, which starts at 9. We hope you'll join us at 9. You'll learn a little bit more about Main Lakes and what we're doing. But then if you want to join at 9:30, you can join then and just jump right into Hillary's presentation. A couple other webinars coming up that might interest folks who are listening. Tomorrow at noon, NRCM has a webinar about sea-run fish, which are integrally tied to Main Lakes. That looks really good. And then the day after, on Friday at 4, Lake Stewards of Maine has a summer series every Friday at 4 o'clock. And this week is Roberta Hill will be talking about the influence of a warming climate on aquatic invaders in Maine Lakes. So 2 good webinars from our friends at NRCM and Lake Stewards of Maine. Just one more quick wrap up. Just if you like what you heard, definitely visit us online, become a member. We'd love to have you. We'll send out the recording in a couple of days. You can share it with your lake association or anybody else. And after this webinar, as you log off, you'll be taken to a very short evaluation. We'd love to hear from you. So thank you so much for joining us. Thank you, Don, for the great information. I think people really were engaged, and I look forward to working on this more with legislators and the Department of Inland Fisheries and Wildlife, DEP. I think there's a lot of great partners out there, and we can take the work that Kezar Lake has done and think about ways to apply it statewide. So it's a pretty exciting topic to be thinking about. So thank you so much. And thanks, everyone, and hopefully we'll see you on June 20th.